Welcome back. We are still in rolling. This is activity 1.3. And this time we're talking about probability with spinners and not number cubes. All right, so it says consider the spinner shown. All sections of the spinner are the same size. An experiment consists of spinning the spinner one time. Now, a question I want you to think about really quickly: why do you think it's important that they noted that all of the sections were the same size? Well, because think about it. If one part was bigger than another, what do you think would happen with that probability? Well, the bigger side will probably have a greater chance, right? So they're noting that because they're saying that all sections of the spinner have the same chance of being selected. Alrighty. Now let's read these questions. It says, number one, how many possible outcomes are there in the experiment, and how did you determine your answer? So, in the last two activities, we talked about outcomes, and also I'm going to skip ahead. Number two, it says list the sample space for the experiment. We talked about what a sample space is. So, if you need to go back and refresh your memory, please do that. All of the vocabulary is, let me keep scrolling, right here in activity 1.1. And then you've got your examples. I'm going back because I want you to start this activity on your own. So in a second, I'm going to have you pause and you're going to answer number one, number two, and then also number three, determine the probability that the spinner lands on a letter. Part A says describe the event and the possible outcomes. So, what are the possible outcomes? And then for 3B, you're going to calculate that probability of it landing on a letter. Then C says describe the complement of the event. Remember what the complement is. We learned that in the last activity in 1.2. And the possible outcomes of the complement. And then also kind of gives you a hint here. It says calculate the probability of it not being a letter. Okay, I'm going to pause this here and I'm going to highlight the ones that I want you to focus on first, which are question number one, question number two, and question number three, to include A, B, and there we go, and C and D. So that whole first page, I want you to work on that first on your own or with a partner. Set your timer for about 4 to 5 minutes. So 4 to 5 minutes, you're completing one, two, and three. Pause here. Alrighty, now that you've had time to work, let's go ahead and compare answers. Alrighty, question number one, how many total outcomes are there? There are six because there are six different sections on the spinner. Number two, the sample space is 1, 2, 3, 5, X, Z, and that can be in any order. So if you did 1, 2, Z, 5, 3, X, and you've got all six in there, then it's still correct. Number three says determine the probability that the spinner lands on a letter. Well, in 3A, we described the event and the possible outcomes, which those were X and Z. So X and Z are the two possible outcomes because they're the only two letters. And then we calculated P parentheses letter parentheses is equal to 2 out of 6, which simplifies to be 1/3. And yes, you have to write it like that every time. P parentheses letter parentheses. That shows probability. That's how we express probability. And then 3C says describe the complement, which is just the opposite. When you think complement, think opposite. So we calculated the probability of it landing on a letter. Well, the opposite is not a letter. So what are the non-letters? Well, that is 1, 2, 3, and 5. And how many are there? Well, there are four. So the probability of it not landing on a letter, so P parentheses, not a letter, parentheses, is equal to 4/6 or 4 out of 6, which simplifies to be 2/3. And notice these complements. I've got 1/3 and 2/3. What do you notice about the sum of those complements? Again, just like you learned in the last activity, they add up to be one whole. So that's how we know that that is correct. Alrighty, and now for number 4 and 5. Again, on your own, I want you to calculate number 4, which is, let's highlight this, the probability that the spinner lands on an odd number. You're going to describe the event, the possible outcome. So, what are the odd numbers? And then calculate that probability and its complement. So, odd numbers and not an odd number. Then, number 5, you're determining the probability of your spinner landing on a vowel. And then, of course, the complement, not a vowel. Now, if you need a reminder of what a vowel is, I will do that for you. A vowel is that is not correct. There we go. Is A, E, I, O, U, and sometimes Y, but we'll leave it out for now. So A, E, I, O, U. Sorry if those letters look really bad, but you get the idea. So at this time, on your own or with a partner, you are completing questions number 4 in its entirety and question number 5 in its entirety. All right. At this time, go ahead and set your timer for 5 minutes max. That's as much time as you need. 5 minutes on the clock. Go ahead and calculate. Pause here. Alrighty, let's compare answers. So for number 4, you found the probability of the spinner landing on an odd number. Well, all of the odd numbers are 1, 3, and 5. So the probability of it being odd is 3 out of 6, which simplifies to be 1 out of 2 or 1/2. And then the complement is it not being odd. So the probability of not being odd, well, there are 3 outcomes, which are 2, X, and Y. And again, that probability is 3 out of 6 and simplifies to be 1/2. Notice again, those complements, 1/2 plus 1/2, those add up to be one whole. Number 5, you found the probability of the spinner landing on a vowel, which were A, E, I, O, and U. And if you notice, there were no vowels on that spinner. So the possible outcomes, there were none. So the probability of selecting a vowel was 0 out of 6, which of course is 0. And then the complement of that is the opposite. So the probability of the spinner landing on something that is not a vowel is 6 out of 6 because all of those outcomes are not vowels. So 6 out of 6 then simplifies to be one whole. And what's 1 plus 0? It is 1. So we know that our complements are correct. All right, let's continue to the last page of this activity. It says the spinner square game is a game at the kid zone. The game consists of spinning the square spinner. If a player takes a spin and the spinner lands on B, the player wins a prize. If the spinner lands on A, the player does not receive a prize. Now notice this spinner, unlike the last spinner, the sections are not all equal sizes. So think, and actually naturally, because if you're landing on B and you do get a prize, but you land on A and you don't get a prize, right? They kind of want you to not win, right? They don't want you to win the prize because the B space is a little smaller, right? But there is a way that we can predict the probability. Think about this first. How do you think we would split this spinner up equally so that we can see exactly how big these sections are? Think about that. While you're thinking, I'm going to give you an idea. Can we maybe split it, say, going this way, and then determine what those sections are? Probably not, because I still don't know what that big and small section are. Could we split it? First of all, I don't like that line. Let's try this again. Okay, there we go. Could we also split it? Ooh, that's really bad. This way to determine what those sections might be worth? No, because I still don't know what the small section for B would represent. Okay, so let's try one more time. Let's see if I can split it this way. Now, do I have equal sections? Nope, but there is something else that I can do, and I know some of you have already figured it out already. I can split it one more time, right down the middle here. And now if we look at these sections, you can see that I've got 1, 2, 3, 4, 5, 6, 7, 8 equal sections. Now, if you got lost in your lines, I'm going to go ahead and highlight the prize section, which is B. So that's right here. So looking at the prize section, B, we can now see the comparison with those equal sections comparing section A and section B. So now let's predict the probability. If I'm predicting the probability of part A, or if it landing on A, I need to first count how many total possible outcomes are there. So there's 1, 2, 3, 4, 5 sections that make up A out of how many total? That is 5, 6, 7, 8. So I know the probability of rolling or spinning in A is 5 out of 8. And now I can do the same thing for B. Go ahead and calculate that on your own. That should have taken 2 seconds. You should have gotten 3 out of 8. And that is a weird looking 3. Let me rewrite that. 3 out of 8. There we go. Alrighty. So now let's move on to the last question of this activity. It says Brittany predicts the probability that the spinner will land on A to be 5. Is Brittany correct? Explain your reasoning. Take about 1 minute and I want you to talk with your neighbor and answer that on your own. So 1 minute to answer that last question. Pause here. Alrighty, let's talk about Brittany's response. So she said that if you spin the spinner, the probability that it'll land on A will be 5. Now, if you're looking at Brittany's answer and you're like, well, yes, she's correct because we got 5 out of 8, then okay, I can see where your thinking is. However, Brittany is not all the way correct, okay? The probability of it being 5 is not correct simply because probability and the chances and likelihood of something happening is expressed in fraction form or decimal form or percent form, because the highest level or the highest probability is one whole, meaning 100% of the time that I spin my spinner, this outcome will happen. Right? Just like we saw, let me scroll up some, scroll up, just like we saw, oops, there we go, in number 5, right? 100% of the time, let me write this so that you can see what I'm talking about. 100% of the time, that spinner was going to land on not a vowel, okay? And the probability of that was 1, 6 out of 6. Now, if Brittany is saying that it is 5, that's essentially saying that if I were to spin it 5 different times, every single time it's going to land on A, but that's not true. So, is she correct? Not all the way. What she should have said is the probability will be 5 out of 8. 5 out of 8 are her chances. Alrighty, this concludes this activity. Great job. You guys have done a lot of learning, and I will see you in the next video.